Usually it's when they're being annoyed and they need to slow down the flow. They can either slow down the beating of the flagella, or they can reduce the paths that go into the sponge. So there do appear to be some contractile tissues. Those tissues and their relationship to the muscle tissues that we'll be talking about with all the other groups, pretty unclear. Okay? But interesting stuff. All right, so we're talking, again, if you've forgotten where we are, we're in the parazoa, right? There is a group of parazoans. It's not on the tree that I told you I had to memorize. I'm just already adding stuff on it, right? There's another very unusual form of life that's found in the parazoa. Parazoa means what? The aside from animals, right? There's the animals, those are the other animals. They're over there because we can't quite figure them out. They don't have true tissues, they don't maybe follow the rules that we put up there. Well, let me introduce you to a great group of organisms called the placozoa. At the moment, it is represented by a single species. That is all that's known. There have been a few described, but most people think that they're all the same. There's no symmetry, there's no organs, there's no muscles, no nerves, no nothing. If you cut into them and look at them, they actually do exist, by the way. It's not just a cartoon. Right? Here's a picture of one. It's just sort of a blob. It just sort of like rummages around in any particular direction. There's no sort of forward, backward, left, and right. It's sort of equal probability of motion. When they want to reproduce, the only thing that's ever been found is they just split in half, and now there's two of you. No sexual reproduction ever been found. In terms of the cells, there are basically two layers, if you'll say, of cells with a number of opaque bodies that nobody has yet figured out what they do. That's the big thing here. But they're covered with cilia. They sort of just crawl around. They secrete enzymes. They secrete mucus. They have some bacterial properties they probably use to maintain their own systems and sort of avoid hangers-on. Aside from that, we know almost nothing about them. Okay? When they were first described, there was actually a lot of disagreement and non-belief that they even existed. But we actually have one of the world's experts on placozoans that lives in Monterey, as a matter of fact. And evidently, if you put out a glass cover slip into our wharf and wait long enough, and you know how to go look for them, they're all over the place. I've never seen one myself, but I can. Okay? So the placozoans are an enigmatic and strange group we don't quite know what to do with. It could be a more degenerate version of something else. Maybe it's a flatworm that sort of has just lost all connection with some of the other characteristics. At the moment, though, it's just sort of put up in the parazoa. We don't know what to do with this. All right. So let's now talk about cnidarians. We've got a little bit of time. At least I can start that process. Feel better about myself. So go to the handout that we brought in today. Okay. So we're heading up into the true animals, the eumetazoa. We're defining true because what makes it true? What do they got? They don't got. They got true tissues. Okay. So true tissues. Now within the eumetazoa, we're going to visit a couple different groups that are bilateral. Obviously, we spent a lot of time over here. We've got a couple different groups over here that are radial. Okay. Your book, trying to sort of stay on the front edge of science, has decided to peel off the ctenophores earlier than the cnidarians. I think that's still a little premature myself. Kudos to them for them trying to sort of be on the cutting edge and not wait 5 years for the scientific community to sort of rally around behind a point, which is usually what happens. But I'm not so sure about that. So I'm going to talk to you about the cnidarians first, okay? For a variety of reasons I'll try to share with you. So let's look at this overall group, the radiata. Again, it's in quotes, which always is a warning to us. Typically, they've got that radial symmetry, as we've looked at. We looked at a number of these radiate phyla, or groups in lab yesterday, right? We looked at the phylum Cnidaria with the hydrozoa, the scyphozoa, the cubozoa, and the anthozoa. And then we're also in lecture only going to talk about the phylum Ctenopus in the floor, which is another of these radiate groups. So within the cnidarians, we'll start there, right? The jellyfish, anemones, as we now know, hydroids, polyps, medusa forms of all different sorts, right? Which include the anthozoan, corals, soft corals, etc. And we had some nice examples of those guys out yesterday in lab. So think about this phylum Cnidaria. let's go back and just review for a moment many of the things we talked about yesterday, which is the radial symmetry, mostly, except for mesomes. Diploblastic level of organization, right? Two tissue layers formed from the early embryogenesis, but carried on through